Today, we are going to take a look at something that actually matches reality. So, in a previous video, we dealt with simple interest. But if you go to any sort of financial institution, it's very, very unlikely that you are going to be offered any sort of simple interest rate. The real world is all about compound interest. And today, you're going to find out how it works. Let's talk about compound interest. Compound interest is calculated on the accumulated amount. In other words, it is calculated on the sum of the principal and any interest earned to date. So the principal plus any interest that you've got at the time that you calculate interest again. So if you recognize that guy over there, you might know that he is Albert Einstein. And he once said, compound interest is the most powerful force in the universe. And if Einstein says something, well, I'd take it seriously if I were you. So let's look at an example. Ntombi deposits 1,000 Rand in a bank account at a compound interest rate of 8% per annum. How much money is in the account after 3 years? So I'm going to use a table here in order to calculate the interest each year. So we start with year 1, and at the start of year 1 we have 1,000 Rand in the account. So the interest for that year is 1,000 Rand times 8%, and we get 80 Rands worth of interest. So at the end of the year we have 1,080 Rand. Then in the second year, the interest is now calculated on the amount that is in the account at the start of the second year. So we are not just calculating interest on the principal, we are calculating interest on the principal plus the interest that we have earned up until that point. So it's 1,080 Rand times 8%, and our annual interest for year 2 is 86 Rand 40. So at the end of the year, we have 1,166 Rand 40 in the account. Now, for year 3, exactly the same thing happens. The 8% interest is calculated on the amount in the account at the start of year 3. So it's 1,166 Rand 40 times 8%, and we get an annual interest of 93 Rand 31. So at the end of year 3, Ntombi has 1,259 Rand and 71 cents in the account. Now, something very important that I want you to notice is that the annual interest that we earn every year becomes more and more. And that's because the interest that you've earned up until that point is included in the interest calculation. So in effect, your interest is earning interest. So the investment increases by more and more each year. Let's see what that looks like on a graph. So on the x-axis, I'm going to put the time period, the year we are in, and on the y-axis, the accumulated amount in the account. And if we plot that, we find that we actually have an exponential graph. So the amount of money in an account that is earning compound interest grows exponentially. Now, is there a formula for this thing? And in fact, there is. The formula is A, the accumulated amount, is equal to the principal times 1 plus I to the power of n. Let's see if we can use that formula in order to solve Ntombi's problem a little bit more quickly. So she's got 1,000 Rand in the account, and we're going to use this formula. So P is the principal amount that we put in at the start, and that is 1,000. I is the interest rate, and that is 8%. And N is the time period, and that is going to be 3 years. So we get that A equals 1,000, 1 plus 8 over 100, because it's 8% to the power of 3, and we are going to get 1,259 and 71 cents, which is exactly the same as we got in the table method, but this was a little bit more quick. So let's keep going. Mr. Einstein, why is compound interest so powerful? Well, let's have a look here. At the age of 5, Gladys receives a 5,000 Rand gift from her uncle. She invests it at an interest rate of 10%. Calculate the accumulated amount that Gladys will have when she retires at the age of 65 if simple interest is earned or if compound interest is earned. So now we can compare compound interest to simple interest. So let's see. If we have simple interest, we have A equals P 1 plus I times N. P is the 5,000, that's the principal amount. Our interest rate is 10%, and from age 5 to 65 is a whole 60 years that she left this investment in an account. So that's going to be N. N is 60, the time period. And after 60 years, she has 35,000 Rand in her account. Geez, that sounds great. But let's hold on. Let's see what compound interest would have given us. So A equals P, 1 plus I to the power of N. And P is still the same amount, I is the same, and N is still the 60 years. So now she would have had 1,522,408 Rand and 20 cents in the account. So the amazing thing about compound interest is that if you're a little bit patient, that exponential growth can take you to really, really large amounts. And most rich people who get rich got there because of compound interest. Up until now, we've spoken about growth. The growth in an accumulated amount in an account under compound interest. But we've only been applying it to money. But there are other things in the world that can grow other than just money. For example, the population of rabbits. So, anything that grows linearly can be modeled using simple interest. And anything that grows exponentially can be modeled or calculated using compound interest. Let's see. Jabu has decided to spend the month of April chopping wood to prepare for winter. I bet his family is very grateful. He already has 60 kilograms of wood, and he estimates he can add 5% of that amount each day. How much wood does Jabu have at the end of April? So now, each increase is going to be the same amount. And we remember that simple interest means that the amount grows by the same over each time period. So we use the simple interest formula. But now the principal, right, is the amount at the start. And that's the 60 kilograms of wood. The interest rate is how much it grows by each period. And that's the 5% that he adds every time. And then the time period is the number of days that he's going to be spending chopping wood, and there are 30 days in April, so that's going to be N. So the accumulated amount at the end of April is going to be 150 kilograms. So there we see we've actually used our linear simple interest formula to calculate something that wasn't just money. Let's look at an application of compound growth. The population of a town in the year 1970 is 10,000 inhabitants. In the year 2000, 20,000 people live in the town. At what rate did the population of the town grow? Now, population growth is always exponential. Because if you have children, your children can have children and their children can have children. So it's kind of like the interest where your interest could earn interest. So we must use the compound interest formula for population growth. So in this instance, we know that the accumulated amount is the 20,000 that is in the year 2000. The principal amount is the 10,000 that we started with. We know that the growth happened for 30 years because it was from 1970 to the year 2000. So N equals 30. So we've got to find I, the rate at which the population grew. So if we divide both sides by 10,000, we get that 2 is going to be equal to 1 plus I to the power of 30. then we've got to take the 30th root of both sides in order to get the power of 30 away from the 1 plus I. So then we get the 30th root of 2 is equal to 1 plus I, and then I is equal to the 30th root of 2 minus 1, and we get that I equals 0,02337, and to turn that into a percentage, we multiply by 100, and that's 2,34%. So the population grew at a compound rate of 2,34%. Now, let's summarize the differences between compound and simple interest. In compound interest, interest is calculated on the accumulated amount. In other words, your interest also earns interest. But for simple interest, interest is only calculated on the principal amount year after year. So you always get the same interest every year. The formula for compound interest is A equals P, 1 plus I to the power of n. And for simple interest, it is A equals P, 1 plus I times n. Then, if we compare it graphically, we find that compound interest is going to grow exponentially, and simple interest is going to grow linearly. And for interest's sake, the only time they will ever be equal is at n equals 1, so after 1 year. It's true what they say about compound interest. If you're not earning it, you're going to end up paying it. So if you want my advice on a get-rich-quick scheme, all you've got to do is get some money, put it in a compound interest bearing account, and forget about it for 50 years. You just have to think of 50 years as being pretty quick.